In this video, we're just going to look at mathematical induction. We're going to use that method of proving to prove a well-known theorem, the Moivre's theorem, of which is just stated on this slide, which states that if you could just take a complex number, raise it to some n integer, positive integer, that would be the same as squaring the r, and also not squaring, raising r with that value, and also multiplying the theta, the angle, by that value, and also the other theta, yes, so on. So we're just going to prove this using mathematical induction. So first, we always test for 1. We try to substitute 1 to check if it is true for 1. If it's true for 1, then we move to test for another integer, of which is integer k. If we assume that it is true for integer k, then we imply that if it's true for integer k, then it should be true for integer k plus 1. So we're just going to take this and prove for 1. We're just going to take this thing, raise it to power 1. If I could raise this thing to power 1, this will be this thing again. And if I put 1 here, it's going to be 1, it's going to be this again. So if I test with 1, integer 1, the right hand side is going to equals to 1, which is also going to equal to your left hand side. They are both going equals to 1. So 1 is there, and we're just going to take let me say k, of which is also an element of positive integers, and assume it is true for k. So let's test for k again. If we substitute k, this is going to be k here, and k here, k here, k here. We assume this one is true, so we just assume it is true. If this one is true, that implies that also k, let me fix my handwriting. That implies that k plus 1 should be true. Okay, so if k is true, then k plus 1 is true. So we're just going to prove that k plus 1 is true. If k plus 1 is true, then k is true, then this is true for all positive integers. So let's get it started. So we have a right hand side and a left hand side that we're just going to compare. So let's look at for k plus 1. So k plus 1, so we just assume that for k it's going to be true. Let's look at it for k plus 1. We're supposed to prove that it should be true for k plus 1. Okay, so let's start it. Let's look at I'll start with looking at the left hand side. So we're going to have r open cos theta plus I sine theta, all raised to, this should be big bracket first, all raised to k plus 1. Okay, whenever you see something plus 1, that means if you see just any binomial exponent, that simply means that there were two let me just write it down. Let me say you have n here, and I should have not used plus. A point A, I have n, I have m, that is going to equal to a n plus m. That is one of your laws of exponent. So this is what you see here. If there is plus, that means there was something of same base, which was r cos theta plus I sine theta. There were two of them. There was also let me close here. There was also r cos theta plus I sin theta. Okay, there were two of these. The other one had an exponent of k, the other one had an exponent of 1. So if you can look here, I could just say if bases are the same, you can take one base and add the exponent, right? So if these are same bases, now I've made it to be same bases, I can add the exponent. It's going to give me exactly this. So I haven't done anything clever, it's still fine. So yeah, but we know something. We know this. We know this. We know this. We have seen this. Not our first time saying this. This was not what we assumed to be equal to this. So instead of this, we could just put this, right? Yeah, I can say it obviously. So just going to say this is going to equal to r k cos k theta plus I sin k theta. Okay, and this side, what are we going to have? This is just 1 there, so 1 doesn't change anything, right? So it's going to be r open cos theta plus I sin theta. Okay, these are same bases, r and r. We could just rk plus 1 again. We're looking at this law of exponent. If bases are the same, take one base and add the exponent. Okay, so yeah, we're here now. So the next thing will be distributing your what? Distributing. This will go to this will go to that. Okay, so let's do it. Hopefully we get correct answer. Okay, so it's going to be cos k theta. This is cos k theta multiplied by cos theta, and then it's going to be plus, that is going to be again cos k theta, this cos k theta multiplied by I sin theta. Okay, good. So we're moving to the next term now. So now we're looking at this, the second term. It goes with this one and also will go to the other one. Okay, so this is going to be this times this is going to be, they're the same, right? It's going to be plus I squared sine squared. Why? Oh, sine. Okay. This one is not squared because it's not the same. This one is k. I didn't see that. Let me just fix that. It's going to be sine k theta. This one and sine theta. Remember, this theta. This I and this I multiplied. Okay. So yes, I've done this and this. Now I'm going to look at sine theta or k theta, because it's the first one, k theta. I forgot about this k, and then I'm out of space now. It's going to be, so we just distributed with the last and the last. Let's look at the last and the first. So it's going to be plus I sin theta and cos theta. The first one is k. Okay, so hope you're following because I have a very bad handwriting when it comes to trig ratios. Okay, but this is okay, you'll see this is sine k theta. Okay, so if you notice this is cos and this is sine cos sine. You know this from your trig. If you did your trig, you'll remember it now. What was this on your trig? Remember on your trick you have this. Let me just remind you if you just forgotten. We had cos. Let me just we had cos. Oh, my cos is bad. we have cos a plus b, which equals to cos a cos b. The sign was different, going to be minus, and sine a sine b, right? Remember this trig ratio. Okay, if you can go back here, you will just see it. Just because it's plus here, right? It's plus here, the sign are not going to be the same, right? Before I keep on, we need to fix something here. I squared, we know from your complex number that is equals to you know it's equals to -1. So we could just erase it and put -1 just to simplify and save my space. This is equals to -1, so it's just going to change that to be -1 minus 1, so it's just minus. So what else we know? Now here we can see what I went there to make a reference of. I came here to make this reference. Hope you see it. Let's come back here. This now, this and this was supposed to be a k here. This should bring up some sense of what I was talking about. Okay, do you know this from your trig? This is going to be your cos. The first angle is k theta plus theta. Okay, and you also know this, right? You should know it. You know this. That was your sine, and it's going to give you what is going to be I. Okay, sine. And the first angle is k plus so it's k. It's let me just fix it. The first angle is what? The first angle is k theta. The second one is theta. Okay, your compound angles. Okay. Then if you can undo this, will bring you this one. Remember here there is minus, but here it's plus. That's how it works. So there's always not. They're always not the same. So I'm out of space. If you still remember, here outside was that's k plus 1 that was been there, and this is where we ended with our compound angles. Okay, from here, we can take out a common factor theta. That is, and we just bring this one down. Arc k plus 1, and then here we can take out a common factor theta. Is going to be cos theta, and if I take theta, it's going to be k plus 1 plus sine. Take out a common factor, is going to be theta. Take out a common factor theta, right? Then I'll be left with, let me just undo it. I'll be left with theta, and then it will be k plus 1, close. And if you notice very well, that was our left hand side, right? It is exactly the same as our right hand side. That's what exactly that's what exactly we're required to prove. Right hand side. Right hand side. So you just go there. This what the theorem said. That if you just go with some integer, that integer will be like that will be same as squaring the radius, multiplying the angle and the angle. So we just proved the theorem that you had to prove. If we reflect back what we did exactly, we just we first proved that it was true for n equals to 1, and then we assumed it was true for k, where k was an element of positive integers. After then we proved that it was true for k plus 1, right? Of which we did. So we can now conclude that the statement is true or the theorem is true by what? Mathematical induction. So we use mathematical induction to prove De Morgan's theorem. So yeah, if you found the video interesting and you want to see more of them, please subscribe. Don't forget to share, and yes, again, subscribe. Thank you.